Hello, everyone. Welcome to Zero Trust Security in DevOps, automating test verification across 5G pipeline. I'm Vijayakumar Venganti, and today we'll explore how Zero Trust transforms security in fast moving 5G DevOps environment. With 5G connections exceeding projections and cybersecurity threats evolving very rapidly, including AI driven attacks, traditional perimeter security is obsolete. Zero Trust is now the baseline, with over 60% of organizations adopting it and plans for 81% by year end, according to recent surveys. This approach enables secure, high velocity deployments without compromising project protection. Now, I will cover the security imperative, the core paradox, why legacy models fail, zero trust fundamentals, embedding in pipelines, the four layer architecture, CI CD implementation, 5G integration challenges, and finally, real world insights and future directions. Let's begin. In the world where we live in, security is no more just a checkbox. It's an enabler of innovation in a high connected world. The rapid adoption of DevOps in 5G has transformed security industry software delivery, but it introduces massive risks. Organizations now deploy code multiple times a day, compressing security reviews. Key issues are these development velocity pressures team expands attack surfaces with each push. Hence, continuous verification is very essential. Perimeter security assumes threats stay outside, but in cloud native architecture, that boundary has dissolved. Recent study highlights that 70% of 5G networks still face misconfiguration vulnerabilities, often from unverified access in dynamic steps. 5G distributed nature with edge computing, network slicing, and massive IoT demands a paradigm shift, no more relying on perimeter. DevOps team face a paradox. Rapid cycles conflict with thorough validation with expanded attack surface. This is even intensified in 5G's complex and faster infrastructure, where infrastructure completely multiplies exponentially. Why traditional models fail? Because legacy assumptions break down. Traditional perimeter based fails as it assumes threats are coming from outside. But this perimeter trust becomes invalid in multi cloud 5G. For instance, Ericsson notes that zero trust matches 5G by eliminating implicit trust, reducing lateral movement by up to 80% in enterprise setups. Static role based access control can't adapt to constantly changing infrastructure. One time authentication leaves unverified windows, and lateral movement goes undetected once inside. A private 5G penetration test case study revealed that without zero trust, industrial networks were vulnerable to insider threats in under 30 minutes. Zero trust is a security model built on simple but powerful idea: never trust, always verify. Key principles of zero trust are every user, device, and service must be continuously authenticated, authorized, continuously validated. It assumes attackers are inside the system already. So you design your system to limit blast radius, detect anomalies quickly, and respond instantly. This philosophy designs systems to contain compromises immediately. As per NIST and CISI guidelines of 5G clouds, Zero Trust reduces breach impact by focusing on data and apps. Integrate Zero Trust into CI/CD pipelines by automating verification at every stage. No manual bottlenecks. That means at code level, that is, sign every commit, run static analysis, scan dependencies, and at container level, image scanning, verify provenance, apply runtime policy, and at the infrastructure level, validate infrastructure as a code, detect configuration drift, and enforce immutability. And finally, at the network level, service mesh with mutual TLS, enforce miss segmentation. The key is automation. Manual review won't work. anymore at this scale. We need automated, consistent checks that execute at machine speed. Propose this four-layer approach, which addresses challenges of securing DevOps workflows in 5G environments. The access layer, transport layer, policy intelligence layer, and control and orchestration layer. The access layer start with continuous identity verification with multi-factor authentication, mutual TLS, container attestation, runtime monitoring. Behavioral analysis detects anomalies. Recent advancements is AI integrates device posture for decision as in Palo Alto Networks NVIDIA AI Factory integration for zero trust in edge AI. The next layer is transport and segmentation layer. Prevents lateral movement via 5G slicing policies, zero trust gateways. AI analyze traffic, auto blocks anomalies, best practice micro segmentation isolates workloads. Yeah, the next layer is policy and intelligence layer. AI driven decisions making uses AI baselines, anomaly detection, dynamic policies, auto containment. It uses adaptive security ecosystem to continuously learn normal behavioral patterns for users, services, and infrastructure. Any deviation from these baselines will be detected as potential threats. Once threats are detected, it adapts policies in real time. AI powered zero trust for 5G slices manages dynamic security without performance hit. The last layer, control and orchestration layer. This layer governs centralized policy with distributed environment. Central government is like a centralized zero trust controller, which is AI powered identity and access management with policy as a code, immutable audits for every run. By providing a feedback loop so that AI risk insights directly update the security posture. This overall four-layer approach ensures distributed enforcement for resilience. You can't trust what you can't see. This layer gives you total visibility. Zero trust implementation in CI CD workflows. Embed at every stage. Signed commits, secret scanning, container analysis, ISC validation, AI anomaly detection. Practical tip is remove static credentials and automate checks for every deployment. Create an immutable chain of custody. Each step creates cryptographic attention, forming a trusted chain from developer to production. Zero trust integration with 5G networks. Leverage 5G slicing for pipeline isolation, edge intelligence for low latency detection, continuous device authentication and isolation. CSG recommends zero trust for CSPs to master 5G security. Implementation challenges and limitations. Some of the challenges are operational complexity, AI attack surfaces, performance overhead, skills gap, and cultural shift. Address these with training and phased adoption. It's not just about the tools, it's about mindset, skill set, and to wrap up, zero trust is no longer an optional. It's a foundational for 5G and cloud native DevOps. It enables fast, safe deployments. It minimizes blast radius. It accelerates automated response. The future is self-healing systems, quantum safe crypto, verified policy correctness. Zero trust is not a destination. It's a mindset, a continuous process, and it's your best defense. With this conclusion, I'll end my session. Please reach out to me if you have any questions. I can be reached out via LinkedIn or email. Thank you so much for joining with me. Thank you.